we're going to now look at turning points, which tend to be some of the easier merit questions. The turning point is where the graph goes from having a negative gradient to a positive gradient, where on the graph it turns. So at this point we see the gradient is negative, and at that point we see it's positive. So in between it is changes from negative to positive, and it is 0 at some point in between. Likewise, up the top we have a point where it's negative, a point where it's positive, and in between must be the point where it turns from being negative to positive, and at that point the gradient is 0. That's the key. The gradient is 0 at the turning points. They're also local maximums or local minimums. Around the blue line, all the points below it are below it, so it's a local maximum. It's not a true maximum because towards the right end of the graph there are higher values. Likewise, at the green line it's a local minimum, but there are other minimum values down here outside that area. So, finding turning points. Finding turning points is usually quite simple. You just have to know that that is where the gradient is 0. You differentiate the function, make that gradient function equal to 0, solve the equation, and write the answer in the context asked. Let's do one. Asked to find the turning points of that cubic. So, the equation is that, and we differentiate it. 3 times 2 is 6, and we lose a power, b squared. 2 times minus 4.5 is minus 9, and we lose a power. 1 times 6, minus 6 here, and the constant disappears as usual. And the gradient is 0 at the turning points, so we can set that our gradient is 0 at the turning point, and our gradient is also equal to this at every point. That, of course, is a quadratic, and we can solve it on our calculator. It's degree 2, it is 6 minus 9 minus 6. When I solve it, the solutions are 2 and minus 5. 2 and minus 5. But I'm asked for the turning points, not the x values, and so I have to translate those into the actual points. Because the graph is a positive cubic, the coefficient is a positive number 2, the graph goes up, turns, and turns up again. So the left hand, the minus 5, which is the left hand of the points, is the local maximum, and the right hand one is the local minimum. So, turning point questions. Actually finding a turning point is relatively easy. The problem is recognizing that that's what they're asking you to do. They can tell you that they want the local maximum or minimum, and you have to know that you find the turning point where the gradient is 0 to find that. Then they can ask for the maximum and minimum value of the function, but that's just the same thing. It's where it's at the local minimum or maximum. They can ask where the gradient changes sign, or, in more complicated questions, when the velocity changes from negative to positive, or rate changes from negative to positive, or something like that. Or they can ask where the tangent is horizontal. We'll do another one. In context this time, what is the maximum value of y if y is equal to 4x minus 1.25x squared? The equation is that, so we differentiate it. 4 moves the x, 2 times 1.25 is 2.5, and we drop 1 power x. The gradient is 0 at the turning point, and the turning point is the maximum. So we make the gradient equal to 0, and the gradient is also equal to our differential. We solve that, it's a fairly simple one. That gives it x is 1.6. But we're not asked what x is, we're asked what the maximum value of y is. So we put our value of x, 1.6, back into our original equation, and there we have it. 4 times 1.6 minus 1.25 times 1.6 squared, back in the original equation, gives 3.2. And that is the maximum value that y has on the graph. So, finding turning points, quite simple, relies on them being where the gradient is 0. Differentiate the function, make that gradient function equal to 0, solve the equation, and answer the question in the context asked. Remember that that turning point is also a local minimum and maximum.